I'm Yijian Zeng. I'm an assistant professor of the Department of Water Resources. So basically, my work is trying to explain from physical processes point of view how the vegetation can grow healthily in a sustainable way. Particularly, think of the past several years. You can see hotter and hotter as well as drier and drier summers. And under such kind of hot and dry conditions, the soil plant system will suffer. But then if you can simulate the benefit of implementing certain measures, you can show the value or economic value very straightforwardly to farmers, to end users, and then they can see the benefit without doing the experiment in reality. For any object, for example, in the physical world, if we want to represent them in a digital world, then we really need to characterize different parameters. If we look at so many models available above ground, you can have vegetation growth model, hydrological model, atmosphere model, soil water flow, soil heat flow, or soil texture information, and also soil erosion. But then in terms of a soil plant system, actually, we need one model to integrate and synthesize all these different components. I think a good example to visualize it is really to hold one soil sample with a transparent bottle, and then that's the object we are talking about. And whatever in the physical world, we try to digitalize it in the digital twin. Of course, there's always kind of how much extent your model can simulate the reality, right? If we want to say something important or something not important, then I want to understand what's the degree. Yeah, you can neglect it. There's so many.
Huge.
Huge. It is huge. Yeah.
Can you list a few?
Like what's the shape of the leaf, the diameter of the stem, the vegetation height, maximum depth of the root can reach, chlorophyll content, hydraulic conductivity, different plant function types, maximum carboxylation rate, electron transport rate. There are also constants. There's also some dynamic parameters. There are so many other things, of course, still many unknowns, but yeah. We still have so much unknown to photosynthesis. We don't understand how this water stress is impacting the photosynthesis and how the nutrients limitation will impact this photosynthesis, and all this will impact the health of soil plant system. We have a certain model, but which is quite, empirical, without really going into the quantum mechanics. But then at least we start to do that and to see how much we can go and how further we can reach. I hope I don't make it the description of the system too complex and then to prevent everyone from using it. But the idea of this soil plant digital thing is really to hide all these complexities. Then you just need to know, okay, this is the soil plant system we want to simulate. Let's say rain grass fields, ecological farming fields, some flowers, some plants. And then if you have some basic information in terms of weather conditions, in terms of soil vegetation parameters, and then you can provide all these parameters to soil plant digital twin. And then you can just click run. Then the soil plant system or soil plant digital twin will give you some answers in terms of evapotranspiration. But then all this can be coupled with another socio-economic model. And then this will help you to understand the impact of climate extremes on the production and on incomes and things like that. So if at the same time you bring, let's say, stakeholders to the field to look, this is what we measured, and this is what we simulated, and this is the effect we saw, then When you have that physical impression, at the same time, you also have this numerical simulation, then it is more convincing than just saying, okay, it is working. But then I need to see the proof. Yeah, I need to see the fact. I need to see the number. I need to see the result. So when I talk to my neighbors, saying, okay, we are working on this project, and then we saw the fusoboss is very resilient to climate extremes, particularly in the past few years, they also got motivated. So we organized a tour to the Granenbeek fusoboss. I made a presentation for them, what the fusoboss looks like and why they are resilient. And then they also fancy about to build a fusoboss in our neighborhood. So now we are trying to go through the week's committee and then to convince everyone, or at least to present the ideas to everyone, to invite their opinions. So this is the current process, but we do design already how it should look like. It's a very draft idea. But then for the numerical part, of course, if I present it, then they will not team up with me because it's about simulation model, right? It's too abstract. We are not trying to convince anyone. We just want to present the facts. And I think that's the way how to involve more and more the community into these topics.